So this is the video lesson for simplifying algebraic fractions. So this is what we call flipping the classroom. Okay, basically you're going to learn the lesson part at home, and in class we're going to practice and make sure we understand it. But this is something that builds on skills that you've already learned this year, so you can learn it at home. So before we go on here, I want you to try questions A through C. So pause the video and do A through C. Now the video is not going to pause itself, so you want to pause and do A through C and make sure that you can get them right. Alright, so hopefully you're watching this after you've paused and tried A through C. So number 1 says we want to factor x squared minus 25. And I hope that we recognize this is our factoring checklist, which always goes GCF first, then dots, then IM. And I hope we recognize that x squared and 25 do not have a greatest common factor, but that it is a difference, a subtraction problem, that it is in fact a subtraction of two perfect squares. X squared is a perfect square, and so is 25. So it is a difference of two squares. So we will factor it as such. So when you factor the difference of two squares, you have two factors. And you ask yourself, what times itself gives you x squared? And the answer is x. Or you can divide the exponent by 2 and get 1 and 1. And then ask yourself, what times itself gives you 25? And the answer is 5. And we alternate the signs so that at the end here, when we multiply negative 5 times positive 5, we get back negative 25. And this would be the answer. And we should all be well versed in this. Alright, so now I'm on to part B here, and I'll write my factoring checklist yet again. So here it is. So now we have x squared minus x minus 20. There's really a negative 1x. And so we look for a greatest common factor first. There is no greatest common factor. There's no letter shared, and there's no number besides 1 shared. This is not the difference of two squares. As you see, we have 3 terms. X squared is a term, negative 1x is a term, and negative 20 is a term. So this is a trinomial, and it's in the form of IM. So we're going to look for two numbers that multiply to negative 20 and that add up to negative 1. And those two numbers turn out to be negative 5 and positive 4. Now, I've taught different kids different ways to factor this, so if you don't do it this way, that's okay. But either way you do it, you should get this answer. You should get x minus 5 times x plus 4. And that's the final answer. So if you use the what times what equals blank method, or if you use the drop-down sign method, you should get this answer. All right, letter C says we want to simplify 6 over 15. So one way to do this, as most people would say, well, okay, I could look and say, well, each of these guys can be divided by 3, and I would get 2 over 5, and that is the answer. However, there's another way to look at this. And one way to look at this is to actually factor 6 and factor 15. So let me show you. 6 is just as good as writing 3 times 2. And I'm using parentheses for a reason, and you'll see later, to represent my multiplication. And 15 factors into 3 times 5. Now I hope that you see the answer to the question when we do this factorization. The answer was 2/5, which if you see, kind of appears right here, which is interesting. And now, so the question is, what happens to the 3's? And I hope that you see that what we have is really 3 divided by 3, which becomes a 1. And 1 times 2/5 is just 2/5. So notice what we did was we took the 6 and we factored it into 3 times 2. We took the 15 and factored it into 3 times 5, and then divided out by a common factor. So we're going to apply this idea to number 1, which is on the next page of my Smart Notebook file. We're going to apply it to number 1, and then we're going to go back up and fill the steps out. So we're going to do number 1 first as a class, or in the video, and then I want to go back and fill out the steps. So here's number 1. It says simplify x squared minus 25 over x squared minus x minus 20. And thinking of my 6 over 15 example, we factored 6 into 3 times 2, we factored 15 into 3 times 5, and divided out by the common factor to get what's left is 2 over 5. So what we're going to do is we're going to do the same thing. We can only get rid of a common factor. So we have to factor the x squared minus 25. And notice, if you notice in the do now, we already did this. We factored this, and it became, actually I want to write it underneath, but the factorization of x squared minus 25 we've done already. I'm going to write it underneath here. We did this blue factorization, so I'll write it in blue. We've factored this into x minus 5 times x plus 5. This was do now question number 1, or do now question A, rather. Then we factor the x squared minus x minus 20 in B. So we've already done this. We already factored. This was my part B factoring, was this problem. Okay? So I'll do this in, let's say, red. Okay? Our do now part B factoring was just x minus 5 times x plus 4. That was your do now B. Now using the purple problem to illustrate here, the 6 over 15, we factored the 6 to become 3 times 2. We factored the 15 to become 3 times 5. Now we factored our numerator, factored our denominator, and what can we do? We can divide out by the common factor. And notice, on top and bottom, we do have a common factor of x minus 5. So we can divide out by it, get 1 over 1, and we know 1 times anything is just the anything. So we can write this thing without the 1s. We can write this just as x plus 5 divided by x plus 4. Now one thing that happens, some students think that the x's here can cancel just as the x minus 5s did. But there's a problem. And the problem is that you are not multiplying by x, you're adding it. You're not multiplying by x in the numerator, you're adding it. And division and addition are not opposites. So this is the final answer. You cannot cancel the x's. You cannot cancel the x's in this situation because they're not common factors. Okay? So for example, if you were to cancel the x's, you would get 5 over 4. But if you plugged in 1 for x, you'd get like 1 plus 5, which is 6, 1 plus 4, which is 5. And so 5 over 4 and 6 over 5 are not equivalent fractions. So you cannot cancel the x's. You can only cancel common factors. This is so important. Alright, so we're now going to go back and fill in our notes. And we're going to basically just describe this procedure that we just did. So steps to simplify an algebraic fraction. you must factor the numerator and factor the denominator and divide out or cancel any common factors. Remember, factors are things that are multiplied together. So I want to walk you through another couple of examples here. So here's one, number 2. Express in simplest form, we have x squared minus 8x minus 9 divided by x squared minus 9x. So we want to factor the numerator. So I have x squared minus 8x minus 9. And I have my little factoring checklist that I always use. So is this a GCF? I don't see any greatest common factor, so it's not. I also don't see, this is the difference of 2 squares. It's 3 terms, so it looks like it's an IM problem, which it is. This time I'll actually use the drop-down sign method that I showed about half the class. So we're going to put our x and our x in our first bays, if you will, and we're going to drop down the middle sign and ask ourselves, a negative times a what gives us a negative? A negative times a positive gives us a negative. And then I'm going to factor the number 9. And 9 factors into 3 times 3 and 9 times 1. My question is, if I put a 3 here, so I'll do this in blue. I want to test different numbers. If I put a 3 here and a 3 there, will a negative 3 and a positive 3 add up to negative 8? And the answer is no. That's what needs to happen in IM factoring. These two numbers that I'm erasing need to add up to the middle number, the negative 8. Well, so now I'm down to 9 and 1, and notice I put the bigger factor first. Now I'm going to ask myself, if I put a 9 and a 1 here, will a negative 9 plus 1 give me negative 8? And the answer is yes. So that's an alternate way to factor that I showed some of the children. So we have this guy, the x squared minus 8x minus 9, this guy here, will now become x minus 9 times x plus 1. So now we have x minus 9 times x plus 1. We're still dividing by x squared minus 9x, but this thing we need to factor, so I'm going to kind of just drag this down a bit here. The x squared minus 9x. And I want to write it down here. So this is x squared, let me get rid of that little dash there, it looks like a negative now. I have my x squared minus 9x. And I have my factoring checklist. So the question is there a greatest common factor? And the answer is there is. Well, I have an x in common with both terms. Notice this guy has x squared and this guy has an x. So there is a common factor, and it's x. And I'll divide by the common factor to figure out what's left in parentheses. I'm undistributing that common factor, essentially. And when I do x squared divided by x, I get x. When I do 9x divided by x, remember the x's go away. Here they cancel because I'm doing 9 times x, not 9 plus x. And I have x minus 9. So now I'm going to go back to the original problem, and I get to fill in my x squared minus 9x, this guy here, with my new factorization. And the new factorization, or the factoring we just came up with, was x times x minus 9. The third thing we get to do is we get to cancel or divide out by the common factors. So guess what? I see an x minus 9 in the numerator and an x minus 9 in the denominator. And those guys get to cancel. And then I'm going to write what's left, and that's going to be my final answer. So what's left is my x plus 1 in the numerator, and the denominator is x. This is the final answer to the problem, x plus 1 over x. That would be the final answer. Okay? I'm going to do one more with you. We're going to do number 3 together. This is a little more challenging. And then your homework, after you watch the video, is to try the rest of the questions in the packet. And so tomorrow I'll put you in groups where you can work on this. You can check your answers, check with me and everything. So we're going to work out one more example as on the video, and you guys are going to do the rest for homework. So it says express 2x squared minus 8 over 2x squared minus 10x plus 12 as a fraction in simplest form. So again, I must take the numerator and denominator and factor them. So we have 2x squared minus 8. And now it's really important to have your checklist, because you're going to see that there are actually going to be two ways to factor this. It's going to be a factoring completely problem, but I didn't tell you to factor completely. You're going to have to figure that out. So is there a GCF? And the answer is yes. If we look numerically, 2 and 8 have a GCF of 2. So I'll factor out the 2, and I'm going to do the rest of this in a different color. If I divide out by the GCF of 2, I'm left with x squared, 2's go away, minus 8 divided by 2 is 4. So the black takes care of the GCF. But then I must look at the red. I have to look at the red part of the problem, and notice that is a dots problem. It is the difference of two perfect squares. So now I'm going to carry my 2 down, and I'm going to factor the red, the x squared minus 4, into x minus 2 times x plus 2. And so that is the numerator factored. Now I'm going to move on to the denominator and factor the denominator. So the denominator was 2x squared minus 10x plus 12. And I'll just use my checklist again. I'm just going to erase the check marks. And so, let me make that 10 and 0 look like a 0. And so now the question is, well, I'm going to go through my checklist. Is there a greatest common factor? And if you look at the numbers, 2, 10, and 12, there is. The GCF is 2. So I'm going to divide out by my 2, and I'm going to write what's left in red. Divide out by my 2. 2x squared divided by 2 is x squared. Negative 10x divided by 2 is negative 5x. And 12 divided by 2 is 6. So I took care of the GCF, but now I have something in red that I must consider. The x squared minus 5x plus 6. It's not the difference of two squares because there are 3 terms. The 3 terms are x squared, negative 5x, and 6. But it looks like it sets up very nicely as an IM problem. We have 3 terms. And so now, I'm going to factor this in red. We have to figure out what our factor pairs are going to be. And this time I'll do it with our blanks method, just to change it up a little bit. So I'm looking for what two numbers. A blank times a blank gives me positive 6. And while at the same time, adding to negative 5. Remember, that's why we put the I and the A and the M's to remember, oh, the numbers have to multiply to 6 and add up to negative 5. So some numbers that multiply to positive 6. Well, think about it. If they multiply to positive 6 and add up to negative 5, the signs must both be negative. So negative times a negative is a positive, and since they add up to two negatives, they add up to a negative, they have to both be negative. So for example, maybe I'll try 6 and 1. Negative 6 times negative 1 is indeed positive 6, but negative 6 plus negative 1 is not negative 5, it's negative 7. So that doesn't work. So I want to try another pair of numbers. Try a whole new pair of numbers. They're both going to be negative again, so I'll leave my signs in. And the answer this time is negative 3 times negative 2 is also positive 6. And lo and behold, negative 3 times negative 2 is also negative 3 plus negative 2 is negative 5. So now I have my factors. I'm going to write my x minus 3 times x minus 2. And so now I have factored both the numerator and denominator. Here are my factored answers. Here's my numerator, here's my denominator. So now to complete the problem, if you remember, we were dividing these two. We were doing 2x squared minus 8 divided by 2x squared minus 10x plus 12. So I'm going to take my new factored answers, I'm going to come down here and I'm going to divide them by each other. So the numerator became 2 times x minus 2 times x plus 2. That's this factored answer. And the denominator is this factored answer. So I'm going to divide by 2 times x minus 3 times x minus 2. And now I get to cancel any common factors. So anything that's basically in a parentheses or outside of 1, as long as I'm multiplying. So I have 2 times lots of stuff on the top and 2 times lots of stuff on the bottom. So these guys divide, these guys divide and become 1. These guys divide and become, let me get rid of that. These guys divide and become 1. And then I notice I have x minus 2 and x minus 2. And they divide and become 1. And so what am I left with, really? I'm left with x plus 2 divided by x minus 3. This would be the final answer. And so your rest of your homework is to try the rest of the problems on the page. We've basically done everything that you know that there is to do with this through these example problems.